So today we're going to be discussing the classification of matter.
So before we can get too far into talking about matter, we should probably just review what it is.
Yep.
And in case you forgot, matter is basically anything that has mass and takes up space. Mm-hmm. So like me right here, I have mass, because if I got on a scale, I'd have, a number would show up. And I take up space. Some might argue more space than I should, but I take it up. Now, the one thing about... Thanks. Now, the thing with matter that's kind of cool is we classify matter within states, solid, liquid, and gas, based on how those particles are actually behaving. So the biggest thing to remember this, if you think back to what we talked about recently, is that state or phase changes are physical changes because you're not changing what it's made out of. It's the same stuff. It's like water, whether it's frozen, liquid, or gas. It's still just H2O. You're not altering it. So if you take ice and you turn it into water, you're melting it. If you go from water to steam, you're evaporating. And then if you go in the opposite direction, steam to water, you're condensing. Water to ice, you're freezing.
Yep.
Now, what's actually happening during all that has to do with what's going on with the little molecules inside. Basically, solids are solid because their particles are moving super slow. So slowly that they're tightly packed to each other. They're very vibrating just a little bit, so they're not really bumping into each other so they don't move too much.
Yeah.
Versus if you heat them up a little bit, you pump some more energy into it, they start to move around a little bit more. They might be a little more flowy, like this, right? That's more like a liquid. They're spaced out just a little bit more, moving around more because they have more energy. And eventually you pump a lot of energy into it, and they start going super fast, lots of massive collisions, and now they're bouncing all over the place. And the speed is greater, so now they're a gas. So if you're a solid, you're really tightly packed because you have low energy, not moving very fast. Medium speed is a liquid. You're a little more loosey, flowy. Fast, gas, think like a fart in the wind.
So if I get this right, what you're saying then is gases move quickly.
True.
So air is a gas. Does that mean air is actually matter?
Yes.
So air is made of stuff. So as we're walking through this, we're actually hitting stuff?
Yep, it's just super small, so we don't really feel it. Which is
Freaky.
good, because if you could feel it and see it, you'd have to be dodging all over the place.
It's neat.
And we'd have black eyes all the time. So within matter, there's two main classifications. You have a pure substance and you have a mixture. Just real quick, I won't give you more details about it, but a pure substance is just like it sounds. It's just one thing throughout the whole thing. If I take that lump of platinum, chop it in half, it's going to be platinum on both sides, exactly the same. Versus concrete, which is a mixture. Depending on where I grab a clump of gooey concrete out of, I might have a little more sand or a little more gravel or whatever. It's not going to be the exact same. So it's not pure.
So basically, pure substance is one thing.
Yep.
Mixture is more than one thing. So that's two or more.
Exactly.
Got it. All right, so if I got this right, then a pure substance, it's got a constant kind of defined composition. What we mean by defined composition is we know what it's made out of. It's made out of one thing that is combined, unchanging. It can't be just separated. You can't just pick them apart. Classic example of this is the elements. If you guys look at our periodic table, the elements, everything listed up there is a pure substance. Yep. It's made of one type of atom. All the way through, it's just that one atom. That's what makes it an element. Carbon, oxygen are classic ones, especially good for us humans.
Einsteinium.
The other kind of pure substance is a compound. It's a pure substance that is made of more than one type of atom, but here's the key part. They're not just mixed up. They're chemically combined. Remember we talked about chemical reactions where we're taking things, we're combining them in new ways? When that combination happens, they are locked together. They become and act as one thing until that bond is broken again. So a compound, even though it's made of a couple types of atoms, or maybe 2, 3, 4, 5 types of atoms, when you get them chemically combined, they become one. So again, pure substances, think of one.
Yep.
Does that make sense, guys?
I think so.
Take an example from, say, H2O. H2O, it's got 2 hydrogen atoms, an oxygen atom, chemically combined, behaves very differently than hydrogen by itself or oxygen by itself. A better example is on the next page. Properties of compounds, separate and together, are crazy different. If you want my very favorite example, I hinted at this in class a little bit, you guys. Sodium. If you take a look there in that picture there's somebody who's cutting a chunk of sodium. Na, it's an element. Sodium by itself is a metal. It is so crazy reactive that it will actually burst into flames in water. You take chlorine gas by itself. If you isolated chlorine gas, diatomic chlorine floating in the air, it's so poisonous and so toxic to human beings, the Geneva Convention banned its use as a weapon in the 1930s because it would liquefy the insides of people's lungs and kill them in a horribly painful way. Happy Halloween. Here's where it all comes together. When you combine sodium and chlorine together, it tastes great on French fries. You have table salt. So two incredibly deadly elements separate. You don't want anywhere near you. You stick them together. Five Guys French fries. Neat.
It's not going to dissolve in my stomach and kill me, is it?
It is not, because they are chemically combined. NaCl together, it's bonded
Oh,
that way.
that's
It's
why it's a
one
compound.
new thing, a compound.
So when you take two things and you put them together into a compound, they have new different properties.
They're not acting on their own. You get a brand new property. Two deadly, horrible properties chemically combined into a new compound. In this case, sodium chloride. It's a totally different animal.
Yummy.
All right, so the next category of matter is a mixture. Okay, now a mixture is matter that is composed of more than one thing all mixed together. And those things that are mixed together are actually pure substances by themselves. They can be elements or they can be compounds. And a mixture can be separated by physical means, meaning you could like pick them apart, or you can do something more aggressive, like say, for example, you have salt water. You want to separate out the salt and the water. You can wait for the water to evaporate, or you could even boil the water and the salt will be left behind in the pot.
Yeah, a big thing to remember with it is that a mixture, they're not chemically combined. Like
Right.
Mr. Harkins was talking about the sodium and the chlorine combined together. That's
Yeah.
a pure substance, so they're chemically combined.
Becomes one thing.
This one, they're not. They're
Yeah.
loosely packed with each
Yeah,
other.
they're kind of just touching each other, but not really chemically combined.
Lazily laying on each
Yes, just hanging out. But anyway, a homogeneous mixture is a mixture that is the same composition throughout. So every little sample of that mixture is going to be pretty much the same. Think of like the ocean. If you take a cup of water from the ocean, pretty much every cup of water is going to have the same exact amount of salt. It's all going to be evenly distributed throughout. You're not going to have a clump of salt here and a clump of salt here. It's all perfectly distributed. Okay? We can also call homogeneous mixtures solutions, if you've heard us use that word before.
Put
That's what
something
we're referring
into
to.
solution. That means it's
Yep.
evenly mixed throughout there.
other. That's some
So,
sciencey terms.
if you've ever made lemonade, for example, you try to evenly distribute all the sugar and the flavoring throughout the water, and it becomes a homogeneous mixture or a solution.
Yep.
Okay? Now, a heterogeneous solution is one that changes in composition throughout. So here's like an example. You like pizza, right, Mr. Black?
You know I love pizza.
Do you like pepperoni on your pizza?
No, but I'll pretend I do.
Okay, thank you for humoring me. So, when you order a pepperoni pizza, that pepperoni,
Pepperoni.
is it perfectly gridded throughout the pizza so that every time you bite into the pizza, you will bite the same exact amount of pepperoni?
No, but I wish it was.
Well,
But can it be?
it's pretty hard to do that, right? I mean,
Yeah,
it
it is.
would take the guy a really long time to sort out that pepperoni.
And it still probably wouldn't be evenly distributed.
Yeah. So anyway, that now it's sorted in a relatively random way on the pizza itself, and the cheese is even imperfect and all that. So since that stuff is not distributed in a very uniform way, we would call that a heterogeneous mixture. Okay.
Okay.
So a few more examples, like a human. Okay, our eyeballs are here. The stuff in our eyes is not evenly distributed throughout our
Yes,
body.
it's
We
true.
wouldn't see very well if that was the
Good
case.
that the parts that you have are in the places that you
Yeah.
have them and those
Yes.
kind of things.
And hopefully they stay there.
And they're not the same all the way through.
Right.
You're not
So-
a sponge.
Another way that I like to go about how you can tell the difference between homogeneous and heterogeneous is if you look at it and you can see different things,
Yeah.
it's heterogeneous.
That's a very simple
That's
way
an
of
easy way
looking
to
at
put
it,
it.
isn't it?
Yeah.
So, so what we'd like you to do is hopefully draw this out in your packet. This is
Little
sort of a
flow
flow
chart.
chart. Yeah, it's a flow chart to get you to determine all different types of matter.
If you want to be awesome, and you all want to be awesome,
For those of you guys that kind of think in pictures, this slide here will help you to kind of take everything we've talked about in this little lesson here and put it into one nice picture. And
Yep.
we can put a star bite to remember this. If you want to click on a couple of these guys, we'll see this all come together.
So,
Matter breaks down into either pure substances,
which
like
would be
elements,
or compounds.
or compounds. And
Yeah.
remember, these things are chemically joined. If they're compounds or elements, it's just one pure thing. But any way you look at it, pure substance is one thing.
notice that picture on the compounds. The reason why it looks like that is because there are different elements put together for
Yes.
that compound. And the other category, if it's not a pure substance, it is a
Mixture.
mixture. Okay,
And
you
there's
could
two
have
kinds of mixtures.
homogeneous mixtures where it's nice and evenly spread
Look
out,
at that one.
or this heterogeneous mixture where it's not-
Random.
Looks
yeah,
like your
it's pretty
sock
random.
drawer at home.
Sweet.
All right.
So that's
Any questions? No?
I didn't hear him
Okay.
say anything,
Yeah.
so they get it fine.
All right.
Perfect.
See you later.